Hey everyone, my name is Sahil Mehta and today I'm going to be telling you guys about my very own Mousetrap car. Let's get to it. So starting with the design, the basic structure is pretty similar to that of a car you would usually see on the road. It has wheels, two spinning axles, a chassis to provide structural rigidity, and a source of power. I chose CDs as my wheels simply to minimize rolling resistance with the ground. Friction at the axles was minimized by hollowing out marker caps and letting the axles spin within them. This way the axles can rotate freely with close to no friction. Friction between the wheels and the ground is nearly zero due to the extremely thin profile of CDs, and this lack of friction presented a problem when setting off because the wheels would spin away all of the energy provided by the mousetrap. In order to counteract this wheel spin, two rubber balloons were wrapped around the driven wheels in order to obtain adequate friction with the ground. In terms of wheels, having one wheel was just absurd. Having two wheels provided no lateral support. Having three wheels was unstable and inconsistent, and having four wheels seemed just right. Having more than four wheels did close to nothing in terms of stability improvements and only added to the total friction with the ground. So now that we've gone over all of the boring stuff on this car, let's get to the powerhouse, the mousetrap. After being set, the mousetrap stores a massive amount of elastic potential energy in its spring. When the trap is triggered, the spring releases that potential energy and converts it into kinetic energy of the lever arm. The kinetic energy of the lever arm is transformed into a combination of elastic potential energy and kinetic energy in the fishing line. Lastly, the kinetic and elastic potential energies transform into rotational kinetic energy in the axle, which drives the wheels. If the lever arm was longer, the kinetic energy of the arm would be higher, and as a result, the rotational energy of the wheels would be greater and the speed of the car would increase. If the lever arm was shorter, kinetic energy of the arm would be lower, resulting in a lower rotational energy and consequently a lower speed. It is obvious to anyone that the car will not move if the mousetrap is not set. This is due to Newton's first law of motion, which states that an object at rest will stay at rest and an object in motion will stay in motion unless acted upon by an outside force. In this case, the outside force that causes movement is the spring of the mousetrap in conjunction with the fishing line. Newton's second law, which states that force equals mass times acceleration, is applicable here because the force applied by the lever arm causes a specific acceleration on the specific mass of the car. The acceleration would change depending on the length of the lever arm. Newton's third law, the law of equal and opposite reactions, is crucial to this car because the driven wheels apply a backward force on the ground, which in turn provides a forward force on the car, propelling it in the forward direction. Alright guys, that was my Mousetrap car. Hopefully you all liked my explanation and reasoning behind it. Thanks for watching, and I'll see you all in class.